Hi, kids. We are looking at 8.2 in Chapter 8 on polynomials, multiply and factoring polynomials. So that means we're going to go backwards and forth where we distribute and then we undo the distribution by factoring. So we're going to start off with a warm-up here. I'm going to ask you to pause your video and do some of these problems and then come back and check your answers. Okay, so what we're doing is we're doing a prime factorization of these numbers. And you can see the first one is done for you with what's called a factor tree. So we're going to start off and we have 72, and we're going to break it into two factors. So I'm going to stick with the 2 because it's even. 2, and then we have times 36, 2 times 36. So if you're not sure, if it ends in an even number, it's even, so you can divide by 2. And then use your calculator if you need to. Now we're going to take 36. Now 2 is prime, so what I'm going to do is I'm going to highlight the 2. And then I'm going to keep going with the 36. So now I know it's even, but I'm going to still say 2, and I could have other numbers like 4 and 9, but I'm going to say 2 times, and I guess I should put the times in here, 2 times 18. 2 is prime, so we're going to highlight that, and then we're going to go to the 18, and we're going to break that into 2 times 9. So I'm going to do that, 2 times 9, 2 times 9, and so 2 is prime. And then I'm going to break down the 9, and that gives us a 3 times 3, and those are also prime. So we have our prime factorization. So we end up with 2, let me see, I'm going to write it down here, 2 times 2 times 2 times 3 times 3. So with that, then that gives us 2 cubed times 3 squared. And there is your prime factorization. Now, either one is a prime factorization, the last one or this one. Okay, so now we're going to try 384. 384, when you break that down, I'm going to say that we could use 4. I'm going to use 2. 2 goes into 38 19 times. So it's 192 times 2 will give you 384, right? So then we're going to break down 192. So that's going to be, again, 2. 2 goes into 19. That would be 9 times, let me see, 96, right? 96 times. Okay, so then we have 2 prime number factors here. And then with that, then we have 96. We have 2 times 48. And 48 is 2 times 24. And now we're getting down to it where we've got all these factors of 2, right? And we can break down the 24 to 4 times 6, right? Or 2 times 12. But now we kind of know if we have 4 times 6, then that's going to be, a 6 is going to be, I'm going to break it off here. That's going to be 2 times 3. And then the 4, of course, is going to be 2 times 2. So what do we have when we write this out? This is then equal to, let me highlight all of the factors of 2 because we have 2 here. And then we have 2 here as well, right? So we got them all. So we have 2 times 2 times 2 times 2 times 2, right? That's 5, 6, 7, 6, 7, and then there's a 3 at the end, right? So times 3. Scooch that over a little bit. Times 3. So we end up, that is equal to 2 to what power? 1, 2, 3, 4, 5, 6, 7 to the 7th power times 3. And there's the prime factorization of that, okay? All right, and then let me see in the next part. Is that 1, 2, 3, 4, 5, 6, 7? Yep, got it. Okay, so 2 to the 7th times 3. And what you can do is you can always check it in your calculator to make sure that your prime factorization is right. So if we take our calculator and use the caret 2 and then caret 7 times 3, and see what we get, except you got to get out of the exponent too. You got to knock it down times 3, and we get 384. So that's correct, okay? So we did the prime factorization because we want to break down numbers like this. We want to place, in this one, the review, place a check mark if the number is a multiple of 10 and an x, the multiple is not a multiple of 10. So it ends in 0, it's a multiple of 10. This is not a multiple of 10. 50 is a multiple of 10, 10 times 5. And 10 times 3 there. So there you have it. Now, the topic in here, a factor, you probably figured that out. A factor is a whole number or variable that divides another whole number with a remainder of 0. So 6 divided by 3 is equal to 2 with a remainder of 0. So 3 is a factor of 6, okay? And I know you know this. And then 6 divided by 4 is 1 plus a remainder of 2. So 4 is not a factor of 6 then, okay? All right, in the next one, you wanted to cross out the expression that does not have x cubed as a factor. That means it really has to have 3 factors of x. So when you look at the first one, x to the 5th is this, expanded. So you've got 3 factors of x, so this is x cubed times x squared. So yes, cross out the expression that does not have. So we're good there. Then we have the 12, which is 3 times 4, but we have an x and an x. So this one does not have x cubed as a factor because there's not 3x factors in there. But if we rewrite this one, we have x times x times x times y. So this is x cubed times y. And so that one is a factor. X cubed is a factor of that one, x cubed times y. And then we have this last one that's going to be 3 squared x squared squared, and you guys know that that's 9x to the 4th. So if we take this one, we get 9 times x times x times x times x. So these 3 factors are the x cubed, so it's 9x cubed times x. So there it is, it is a factor. Circle the factor tree that shows prime factorization. So you can see 6 has factors of 2 times 3, so you're done there. Even the other one, this is x times x. Here we have a 2 times 3 times x there, so neither one of those. And the same thing here, we have a 2 times x, and these are just, we want to put the numbers together and then the factors together like that. So that one is not prime factorized. But the last one, you can see the 2 and 3 are prime, and the x's are also prime also. There you go, there you have it. Okay, now for the new lesson. So now, we're going to do a couple examples. I'm probably going to spend 2 videos on this, but we're going to start off now where we want to multiply by a monomial. Remember, a monomial is one term. So this 5n is a monomial factor, if you will. And we're going to distribute this. We're going to distribute that 5n to 3 terms. So I'm going to take a little bit of time and get the simpler form by doing the distribution. So we're going to distribute, but I'm going to say 5n, we're going to multiply times 3n cubed. And then we're going to stick that minus sign in, and then we have 5n times 2n squared, 5n times 2n squared, and then we end up here with 5n times, so it's plus 5n times 18. Okay, so now when I multiply these together, I hope you can see the number factors go together, and we did a lot of work on that, so hopefully you'll see what I get here. So then the second part, so I distributed the 5n, check, that's the first step. The simplified form is going to be this. I'm going to take this first term in purple, and we're going to write that as 5 times 3 is 15, and n to the first power times n cubed is going to give me n to the 4th. Bring down the minus sign. The second term is going to be the 5 times 2, which is going to be 10. And then we have an n to the first times n squared, which is going to be n cubed. And then the last term there, we're going to have 5 times 18, which is 50, plus 40, which is 90. So we end up with just plus 90 and then bring the n down. It's an n to the first, so we just tack that in there, okay? And there is a simplified form of 5n. Dry throat, hold on. All right, the next one, we're finding the greatest common factor of these 3 terms. Now, there are 2 things at bay here, numbers and variable factors. So I like to do them separately when I do these. Now, I want to find the greatest common factor, GCF, of the following 3 terms. So I've got 3, -9, and 12. So what I'm going to do is I'm going to say these right above. Now, when I see a common factor, which you know 3 goes into all 3 of those, I'm going to just say 3 times 1 here. And then I'm going to say this is 3 times -3, but I'm going to say 3 times 3 times -1. And then I'm going to say 3 times 4 times -1 here. So I want a common factor. So if I look at all three of these products, you see there's a 3 in all of them that's in common. So now there are times where we can pull out a negative sign as well. We're not going to do that. We're going to look for the whole number factor right now that's positive here, okay? So if we decide we want to pull out a negative or want to get a GCF that's negative, we'll talk about that. Now find the GCF of x to the 4th. So we could do all the factors here, but you see how this is x times x cubed, and this second one is x times x, and this last one is just x. So if it's common to all, you can only have one that's a common factor to all. If I wanted to put an x times 1 there, I could. But so the GCF for the x terms that you see in number 2 would just be x. In fact, the GCF for the variable type is always going to be the one with the lowest power, okay? So the lowest power of x will be the GCF. So if we look at the GCF of all three of these, it's going to be 3x. That would be the greatest common factor. So now, the next one, we're going to factor out a monomial, but we're going to look at the factor tree first. So what we're going to do is we're going to factor 15x to the 4th with partial factors already out there. So 15x to the 4th, we're going to factor that as 3x times 5x cubed, okay? Because 3 times 5 is 15, and x times x cubed is x to the 4th. Okay, now if you look over here to the left, we've got 3 and x as factors. And then this tree branch is coming down where we have a 5x times something and the 5 and the x. So all of those are going to be part of our prime factorization for 15x to the 4th. So now I'm going to come back and I've got this next number, 5x times x squared. Okay, because 5x times x squared gives us 5x cubed. So that's what we're breaking down there in this one. Boom, boom. And then now this last one, we're going to break down x squared, and we break that down to x times x. So I meant to put the multiplication symbols in here, though, for those, okay? All right, so now let me highlight the greatest common factors here, or the prime factorization factors, so that if I look at this, down on the line here, we have, I'm going to factor. After writing the factorization, circle the common factors, right? So we're just going to write this one down in the line here. So we're going to start off, you see the numbers? I'm going to write a 3 times 5. And then I've got, if I check here, and then I've got a 5 times x. So I have x. 3 times x is, x goes here, x, and then 2 more x's. Okay? Now that should be right, 15x to the 4th, okay? Now, for 12x squared, we have 2x times, and you guys probably guessed it, it's 6x, right? So you have 2 times x here. That's prime. Those are prime factors. And then the 6x goes to 3x times 2. 2 is prime. And then I have, it's all done then, because you've got the 3 and the x. So now everything in yellow, so if I put that down, I'm going to put the numbers down 3 and 2 first. So I'm going to put it in that order, 3 times 2 times. And how many factors of x do we get? Just 2. X times x, here and here, right? So that, this, and then that's your extra factor of 2 there. It would be 3x times 2, but we need that 2 for the factoring. Okay, so we had 12x squared is equal to, oh, and I'm missing that too. It's so funny. Here, up, and I'm going to leave it like that. I meant to put 2 of those in there. It's 2. So in this case, now we've got our factoring laid out. So after writing the factorization, circle the common factors. So we're going to go here. We're going to say, all right, there's a common 3, right? So I'm going to put the GCF, there's a 3 in it. And then I've got a common x. And then I've got another common x, and we're done there, right? So it's going to be 3 times x, which is equal to 3x squared. And there you have it. Okay? All right. So that gives us the common factor there. Greatest common factor, in fact. Okay, so we will find the factored form of the expression. Now, multiply them all, and then now what we want to do, now that we know the GCF is equal to 3x, now we're going to take this and we're going to factor this out. One of the things I like to do initially when students find that this is a little bit difficult is I like to take each term and split it up, like so. Like 3x squared is our GCF, right? So what is that going to be times? That's going to be times 3x to the fourth. Then I'm going to bring my plus sign down. And then I've got 3, let me use purple here, 3x squared, and then that's going to be times, 3 times 5 is 15. So it's going to be 5x cubed. And if you look at your prime factorization, oops, wait a minute, 15x squared. So am I missing one? No, that is going to be just to the first power, right? To the second power, I'm sorry. So we have 3x squared times, so now for the last term, we get plus 3x squared is our GCF. And then we're going to multiply that by, I need another color, so let's go light blue. So that's going to be 4, okay? So just 4 is left. So now if we highlight the 3x squared in each term, that's what we're going to pull out using the reverse of the distributive property. Now, the pink, green, and light blue terms are what's left when we pull out that 3x squared. So you're going to pull it out using the reverse of the distributive property. You're going to put up a parenthesis, and then you're going to bring down your terms that are remaining because they have to stay inside that grouping. So we have 3x to the fourth plus, there's that plus sign, 5x squared, and then that's plus 4. So this, my dear people, is the factored form for the polynomial 9x to the 6th plus 15x to the 4th plus 12x squared. Now I have a couple other problems to finish up with, but I'm going to pause the video here, stop the video, and pick up with video 2. Okay? I'll see you when I see you. Alanator out.